Chain rule, presented by Hyung Kim and Edmond. Chain rule is a formula used to find derivatives of two or more functions. The form of f of x is given by the following. F of x equals g of h of x, and its derivative is the derivative of f of x equals the derivative of g of h of x times derivative of h of x. First, separate the outside, then the inside function to find the derivatives of a composition. A helpful table for the chain rule and compositions. This table shows the relationship between f of x and the derivative of f of x. Some useful examples are the x to the power of n, which the derivative is n times x to the power of n minus 1, and the one of sine x, and its derivative is cosine x, and the derivative of cosine x is negative sine x.
Next problem we have the square root of x squared plus 1 over x squared. This can be rewritten as x squared plus 1 over x squared to the power of 1 half. Now we can find the derivative of the outside function, which is the power of 1 half. We get 1 half times x squared plus 1 over x squared to the power of negative 1 half. Remember that we have to subtract 1 half by 1, which is why we have negative 1 half. Now we can find the derivative of the inside function, which is x squared plus 1 over x squared. Remember that 1 over x squared can be rewritten as x to the power of negative 2. So the derivative would be 2x minus 2x to the power of negative 3. We can simplify this, and we get 2 times x minus 1 over x cubed. Now we can multiply the two derivatives together, and the final result will be x squared plus 1 over x squared to the power of negative 1 half times x minus 1 over x cubed. We have the cubic root of 1 minus sine x. We can rewrite this as 1 minus sine x to the power of 1/3. Now we can find the derivative of the outside function, which is the power of 1/3, and we get 1/3 times 1 minus sine x to the power of negative 2/3. Now we have to find the derivative of the inside function, which is 1 minus sine x. 1 has no derivative, and sine x turns into cosine x, and we get negative cosine x for the derivative of the inside function. Now we have to multiply these two derivatives together, and we get negative 1/3 cosine x times 1 minus sine x to the power of negative 2/3, which is the final answer to this problem.
This is an easy example that applies the rule of x to the power of n equals the derivative of n times x to the power of n minus 1. The given equation is f of x equals x to the power of 20 over 7. The derivative equals 20 over 7 times 1, which is 20 over 7. This is the previous exponent and now has become the coefficient, times the variable x, which is given, to the power of 13 over 7. Why 13 over 7? Since 20 over 7 minus 7 over 7, which is 1, gives 13 over 7. 13 over 7 is the exponent of the new derivative of x. This is an easy example of chain rule that uses the function of a number without any exponent, and therefore its derivative equals 0. The function f of z is given by the equation 7 minus 6z squared to the power of 15. Its derivative is 15 times 1 times 7 minus 6z squared to the power of 14, since it's 15 minus 1, times the inside function of the derivative of 7 minus 6z squared. Now the derivative is given by the equation 15 times 7 and minus 6z squared to the power of 14 times 0, which is 7. 7 doesn't have any exponent, so it's 0, minus 2 times 6, 12 z to the power of 1. And the final result is negative 180, since it's negative 12 times 15 z times 7 minus 6 squared to the power of 14. The fifth example uses a sine in an equation and its derivative is a cosine. So the equation f of x is described as sine 10x. The derivative of f of x is cosine, since the derivative of sine is a cosine, and leaves 10x times the derivative of 10 of x, since this is the inside function. And then you get cosine 10x times 10, since it's 10 times 1, and you take out the x, and the final result is 10 times cosine 10x.
The next problem we have 8 times cosine of x to the power of 5. First find the derivative of the outside function, which is the power of 5, and we get 40 cosine x to the power of 4. We multiplied 8 times 5 and subtracted 1 from 5. Now we find the derivative of the inside function, which is cosine x. And the derivative of the cosine is just negative sign. Now we multiply these two derivatives together and we get negative 40 sine x times cosine of